All right, the first question asks how many equivalents per mole are provided by magnesium lactate. We can start out by deriving the formula for this. Magnesium has a charge of 2. Lactate has a charge of -1. And so we can crisscross those superscripts to get the subscripts. That means there'll be 1 magnesium and 2 lactates in the salt. And then the shorthand way to get equivalents per mole is to pick either one of these and multiply the subscript by the superscript. Just multiply those together, and that gives you the equivalents per mole for the salt. And you'd see that you'd get the same answer by multiplying subscript 1, superscript 2 for magnesium. Next question is, what is the concentration of a 10 normal solution of magnesium lactate in grams per mil? Normal, we just learned, is 10 equivalents per liter. So normal is equivalents per liter. We have 10 equivalents per liter of magnesium lactate, and we want to know what that is in grams per mil. So we have to convert the liters to milliliters and the equivalents into grams. So the bottom one's easy. There's 1,000 milliliters for a liter, so we can put in 1,000 on the bottom. For the top one, we're going to have to do that in 2 steps. So we know the number of equivalents per mole for this salt. There are 2 equivalents per mole, and we need to know, first of all, how many moles are provided by 10 equivalents. So X equals 5 moles. And then the next step is going to be to convert those moles into grams. And for that, we need the molecular weight. We know the formula from what we did in the first problem. Magnesium 1, lactate 2. So 1 magnesium with an atomic mass of 24 plus 2 lactates, each with a molecular weight of 89, and that should give us 202 grams per mole for the salt. Okay, so 202 grams for every 1 mole. So how many grams from 5 moles? And for this one, X will equal, looks like 1,010 grams. All right, so we have the number of grams now here, and we have the number of milliliters here. So to finish off the problem, we'll have 10 grams divided by 1,000 milliliters, and that will be 1.01 grams per milliliter. Okay, last question. We have a blood potassium reading of 15 milligrams percent, and this is just the ion by itself. So potassium with a charge of +1. We want to know what the concentration will be in milliequivalents per liter. So milligrams percent is 15 milligrams per 100 milliliters. 100 mil has to go to liters. The milligrams have to go to milliequivalents. We can do the volume first. How many liters if there's 1,000 mils per liter, and X should equal 0.1 liter. Okay, so we've got the bottom taken care of. And then for the top, we need to kind of reverse what we did up here, the second problem, go from milligrams into millimoles. So we can do a shortcut here. We don't have to go milligrams to grams and then grams to equivalents and then equivalents to milliequivalents. We can find out how many millimoles are represented by 15 milligrams using the molecular weight we already calculated. And this might be a good opportunity to show how this works. If there are 202 grams per 1 mole, and we have to multiply grams by 1,000 to get milligrams, and if we have to multiply moles by 1,000 to get millimoles, then what's the milligrams per millimole going to be? Well, these will cancel out. The number for milligrams per millimole is the same as the number for grams per mole. And so anytime you change the top and the bottom by the same amount, you can use the same value. So we can put in 202 milligrams in 1 millimole up here and save ourselves some extra proportions that we have to do. So crisscross, X for that looks like it's going to be 0.385 millimole. And then we have to convert that to milliequivalents. And the same concept applies here between equivalents per mole and milliequivalents per millimole. For potassium, where there's one ion with a charge of +1, then it's going to be 1 equivalent per mole. And that's the same as 1 milliequivalent per millimole. And so to convert this to milliequivalents, let's just write it out for fun. 385 millimoles. And we want to know, well, up here, how many milliequivalents is that? Given that there's 1 milliequivalent per millimole. And we see that we're going to end up with the same value. So X is 0.385 milliequivalents. We just multiply and divide by 1 there. All right, so we have this value for milliequivalents. That was our stopping point. Now we have the volume in liters, we have the milligrams in milliequivalents, and we just have to divide them to get the final answer. So 0.385 milliequivalents divided by 0.1 liter, and that is 3.85 milliequivalents per liter.